Have you ever wondered what sparks a nuclear chain reaction? What determines if a lump of uranium, for instance, will simply sit there, or if it will unleash an atomic explosion? The answer lies in a concept known as critical mass. Imagine holding a piece of uranium in your hand. It's heavy, dense, and slightly warm to the touch. This piece of uranium contains billions upon billions of atoms, each one a potential source of incredible energy. But right now, it's just a lump of metal. Why? Because it hasn't reached its critical mass. Critical mass is the smallest amount of fissile material, like uranium or plutonium, necessary to sustain a nuclear chain reaction. Think of it as the tipping point. Below this point, any nuclear reaction will fizzle out. Above it, a chain reaction can become self-sustaining and even increase in power. But what factors determine this critical mass? It's not just about the amount of material. The nuclear properties of the fissile material, its density, shape, enrichment, purity, temperature, and surroundings all play a role. A subcritical mass, where the amount of fissile material is below the critical mass, cannot sustain a chain reaction. The neutron activity within it will decrease exponentially. A supercritical mass, on the other hand, is where the amount of fissile material exceeds the critical mass. Once a nuclear reaction has started in a supercritical mass, it will proceed at an increasing rate. However, it's essential to understand that the critical mass isn't fixed. It can be changed by modifying factors like the fuel used, the shape of the material, its temperature, and its density. Even the presence of a neutron-reflective substance can affect it. In essence, critical mass is a delicate balance. It's a fine line between a piece of fissile material merely existing and it triggering a powerful nuclear reaction. To sum up, the critical mass is the smallest amount of fissile material needed for a sustained nuclear chain reaction. It depends on various factors like nuclear properties, density, shape, enrichment, purity, temperature, and surroundings. Below this point, the material is subcritical and cannot sustain a chain reaction. Above it, the material is supercritical and can undergo a chain reaction at an increasing rate. The critical mass can be changed by altering factors like fuel, shape, temperature, density, and the presence of a neutron-reflective substance. So the next time you see a piece of uranium or plutonium, remember that it's not just the amount of material that matters. It's a complex interplay of factors that decide whether it will lie dormant or unleash the immense power of the atom.